Hi, so today we are going to be focusing on Eureka Math, third grade, Module 3, Lesson 11. The objective for this lesson is to understand the function of parentheses and apply this knowledge to solving problems. So basically, we're using parentheses in math problems. That's it. Now we're going to start with our application problem. And it says Richard has 2 cartons with 6 eggs in each. As he opens the cartons, he drops 2 eggs. How many unbroken eggs does Richard have left? Now, this is actually a multi-step problem. It's 2 steps involved to this problem. Now, there are a few ways to solve it. Now, most of the time when my students see the word each, they automatically write a get chart, right? Groups, each, total. They do this to figure out whether they are multiplying or dividing. After you write your get chart, you reread the question. So it says Richard has 2 cartons with 6 eggs in each. 2 cartons. That would be my groups. 2 cartons. And it would have 6 eggs in each. 6 eggs in each. So we have 2 cartons with 6 eggs in each. All right. We don't know our total. So first we need to figure out how many eggs we have. Well, we have 2 times 6 eggs. That would give us our total. 2 times 6 is 12. So that means that we have a total of 12 eggs. And I have my students write it all the way out because when they write it out, they can actually see where they receive the numbers from, what the numbers mean. All right, now, as I said, this is a 2-part problem. So we know how many eggs he has because at first it just says he has 2 cartons with 6 eggs each. And he has 12 eggs total. Now, as he opens the carton, he drops 12 eggs. Well, at first he had 12 eggs, but he dropped 2. So when he dropped those 2, that means that we have to subtract 12 eggs minus the 2 that he dropped. Is 10 eggs. So he has 10 eggs left. Now, as I said before, there is more than one way to solve this problem. I do have some students that prefer to draw models. That's fine. This is a type of model, right? But they like to draw picture models or pictorial models, which is fine. So if that's the case, they would have drawn something that looks a little like this. And I'll just draw it here on the side. So he has 2 cartons. This would be carton number 1, carton number 2. 2 cartons. C1 for carton 1, C2 for carton 2. All right. And there are 6 eggs in each carton. As he opened the cartons, he dropped 2 eggs. How many unbroken eggs does Richard have left? 6, 7, 8, 9, 10. Either way, it's correct. So if you have a student that likes to draw a pictorial model, that's fine. If you have a student that likes to create a get chart as they've learned in class, that's also fine. If you have a student that likes to draw an array, that works as well. So they could have drawn 2 rows of 6 and then crossed out 2 eggs. Or they could have done a strip diagram, 2 boxes of 6. And then subtract it from there. So there are several ways to solve this problem. As long as the answer that they come up with is 10, then that's all that matters. Now we're going to go ahead and move on to the problem set. Okay, so now we're going to get started with the problem set for Lesson 11's lesson. And again, our lesson is all about understanding the function, which means the purpose of parentheses. All right, so The main takeaway from this lesson is to ensure that students know that you're supposed to complete the operation inside of the parentheses first. And then after you do that, you can perform the rest of the operation that's involved in solving the problem. So let's start with A. Inside the parentheses, you see 12 minus 4. Well, solve that first. What's 12 minus 4? 12 minus 4 is 8. So you would write 8 here and then tell them, all right, now we've solved inside of the parentheses, right? So now we just perform the rest of the operation that's left. Well, what's left is to add 6. 8 plus 6. And that's 14. Now notice for letter B, the parentheses is in a different place. So again, we solve what's inside of the parentheses first. 4 plus 6. Just write that below it. That's 10. All right, and now we solve the rest of the operation, or we use what's left to complete the operation. 12 minus 10, which is 2. Now, here we notice we have the same numbers that are involved in both problems, but the only difference is the location of the parentheses. Solving the equation inside of the parentheses first changes the answer. Now, that's not always true because it really depends on what operation you're performing. But in this case, it does. But we will see some questions where even though the parentheses are in two different places, it doesn't change the answer. The answer will remain the same. Okay, so let's move on to C. Inside the parentheses, we have 7 plus 3, so we'll solve that first. And I'll switch to a pen because the marker is a little bulky for this. So 7 plus 3 is 10. 15 minus 10, that's 5. Again, solve inside of the parentheses. 15 minus 7 is 8. 8 plus 3 is 11. Solve inside the parentheses first. 3 plus 2 is 5. 5 times 6 is 30. Solve in the parentheses first. 2 times 6 is 12. 3 plus 12 is 15. 7 minus 2 is 5. And 4 times 5 is 20. 4 times 7 is 28. 28 minus 2 is 26. Moving on to this side, we have 12 divided by 2, which is 6. 6 plus 4 is 10. 2 plus 4 is 6. And 12 divided by 6 is 2. 15 divided by 3 is 5. And 9 plus 5 is 14. 9 plus 15 is 24. And 24 divided by 3 is 8. Excuse me. 10 minus 4 is 6. And 60 plus 6 is 66. 60 divided by 10 is 6. And 6 minus 4 is 2. 10 divided by 5 is 2. And 35 plus 2 is 37. 35 plus 10 is 45. And 45 divided by 5 is 9. Now we're going to move on to the bottom portion. And here it says, use parentheses to make the equations true. So the answer that we're trying to obtain is here. And we have to put the parentheses in the correct location in order to obtain the correct answer. All right, so first we start with 16 minus 4. Well, 16 minus 4 is 12, and 12 plus 7 is 19. So we put the parentheses here. And we write it out above there, just so that they can see it. All right, let's look at B. Now, we can't put the parentheses in the same location, right? So it should be automatic for them to know, hey, if I put the parentheses in the same location, I'm going to end up with the same answer. So I have to move the parentheses over. So I'm going to put the parentheses around the 4 and the 7. 7 plus 4 is 11. And 16 minus 11 is 5. Let's look at C. 15 plus 5 is 20. And 22 minus 20 is 2. So that would work. That's true. So again, same thing. We know that if we put the parentheses in the same exact location, we're going to get the same exact answer. And we're looking for 12 this time, not 2. So we're going to move those parentheses over. 22 minus 15 is 7. And 7 plus 5 is 12. I like how they put the answer on the opposite side this time, because a lot of times, especially for my students who are taking standardized tests like the STAR test, they're not going to always put the answer or the sum or the product or the quotient, whatever type of problem you're doing. They're not always going to put the answer on the right. Sometimes they're going to put it on the left. So it's important that they know to still solve it the same way, no matter the position of the answer. Okay, let's do the next one. 3 plus 7 is 10, and 10 times 6 is 60. All right, let's look at the next problem. Again, we cannot put in the same location. It'll give us the same answer. So we know we have to move it. All right, 7 times 6 is 42, and 3 plus 42 is 45. Let's move on to G. 10 divided by 10 is 1, and 1 times 5 is 5. Now, notice what they did here. They gave us different numbers. Look. Different numbers. We have different numbers here. So, let's see if we put the parentheses in the same place, if we're going to end up with the result that we want, the answer that we want. So 100 divided by 10 is 10, and 10 times 5 is 50. Now look at that. We put the parentheses in the same place, right? But we ended up with a different answer. And so that's one of those things that they may have a test, or they might see it on the STAR test, where they're like, okay, well, there's a pattern, right? I have to move the parentheses to a different location because that's going to give me a different answer. And these numbers are very similar, very, very similar. So if they're not paying attention, they'll just move the parentheses because they think that they're supposed to, instead of actually having to. So we have to make sure that we coach our babies into making sure that they pay attention to the actual numbers in the problem and not just always look for patterns as far as solving the problems. Okay, let's move on to I. 26 minus 5 is 21, and 21 divided by 7 is 3. So yeah, that works. We'll put our parentheses here. All right. Again, different numbers. But at this point, you'll notice that as we go through and we gain a little momentum and we get a little rhythm about doing it so that they see that depending on where the parentheses are, depends on what the answer is, they get in the habit of not just relying on, oh, I'm going to put the parentheses around the first two numbers and that'll make sure my answer is correct. Sometimes it takes trial and error. All right, so they may see this and then they'll get scared because they're like, oh, that's kind of big. 4 times 25. Well, I know 4 times 25 is 100, and 100 minus 16 is definitely not going to give me 36. So let's go ahead and move the parentheses over a little bit and do 25 minus 16. Well, 25 minus 16 is going to give me 9, and 4 times 9 is 36. All right, now let's go ahead and move on to the next page. And we're still in our problem set. And we're looking at number 3. Number 3 says the teacher writes 24 divided by 4 plus 2 equals unknown on the board. Chad says it equals 8. Excuse me. Samir says it equals 4. Explain how placing the parentheses in the equation can make both answers true. All right, so let's look at it from both students' point of view. All right, Chad says that it equals 8. And Samir says that it equals 4. Okay, so 24 divided by 4 plus 2. 24 divided by 4 plus 2. Now it says explain how placing the parentheses in the equation can make both answers true. Again, we have to solve what's inside the parentheses first. All right, so let's put our parentheses here first. That would be 24 divided by 4, which is 6, plus 2. And that definitely would equal 8. And if we moved our parentheses over to where it showed as 24 divided by 4 plus 2 in the parentheses, which equals 6. 24 divided by 6 is 4. So, as you can see, by placing the parentheses in different places, both students are correct. So obviously, Chad placed his parentheses around the first two numbers, and Samir placed his parentheses around the second two numbers. Let's look at number 4. Natasha solves the equation below by finding the sum of 5 and 12. Now, sum means that you're adding, all right? So, she solved it by finding the sum of 5 and 12. So that means she did this. Okay. Write a little note to yourself. Now, place the parentheses in the equation to show her thinking. Okay. So, if I were to place the parentheses, first, I'm worried because there's no 5 here. There's only a 15 that's close, right? That's not 5. It's not 5. So I just do this because that's as close as we're going to get, right? And so then I solve 12 plus 15. Well, that's 27. And we divide that by 3, and that's 9. Now, here it could be a typo in the book, but I know for a fact that my student's going to be like, well, there's no 5, Miss Jones. So she can't solve her problem because she has the wrong numbers. Okay, so I feel like in this case, this is just one of those questions that might be flawed. It might have been just a typo in the book. However, this is the answer that she would have gotten had she put the parentheses around the first two numbers. Now, if she had placed the parentheses around the last two numbers, however, then she would have gotten 12 plus 5, because 15 divided by 3 is 5. So she actually went ahead and solved part of the equation by placing a parentheses there and then adding. Now that would have given you 17. So on one hand, if you would have gone ahead and placed a parentheses around the first two numbers, you would have been like, hey, something's wrong. There's no 5 in this problem. There's no 5. But if you would have said, well, you know what? Let me problem solve. Let me see if she did this a different way, right? And she did. She had to, because she still ended up with finding the sum of 12 and 5, right? But she placed the parentheses around the last two numbers, giving her 5 as one of the numbers that she was adding. So we actually showed Natasha's thinking. Now let's go ahead and move on to number 5, where it says, find two possible answers to the expression 7 plus 3 times 2 by placing the parentheses in different places. Well, I'm going to write the equation out first here, and then do it again here. And I'm going to place my parentheses around the first two numbers here and around the last two numbers there. All right, let's solve. 7 plus 3 is 10 times 2, which is 20. And here I have 3 times 2, which is 6. And 7 plus 6 is 13. Same numbers in the equation, but the location of the parentheses changed the solution. Okay, now we're going to move on to solve the exit ticket. So here it says use parentheses to make the equations true. All right, now 32 minus 14 plus 6. Just looking at the equation, I know that 14 plus 6 is 20. And 32 minus 20 is definitely not going to give me 24. So that means I'm going to have to place the parentheses here. Now, does it say right above the problem to show your thinking? It doesn't, but I do like to have my students write above the parentheses to show what the answer is inside of the parentheses so that they can actually see the math involved in the problem. So 32 minus 14 is 18 plus 6, which is 24. And for B, the answer is different. Numbers are the same. Answer is different. All right, so here, we can put the parentheses here. 14 plus 6 is 20, and 32 minus 20 is 12. But again, that's one of those things where you have to make sure that you pay attention and have the students pay attention to all of the numbers in the problem and not just be lazy and say, hey, these numbers are similar, so it must be a similar or the same problem. It's not. It's not. All right, let's look at C. 2 plus 8 times 7. Okay, well, I know that 2 plus 8 is 10, and 10 times 7 is 70. Now, if I tried that here, I'd end up with 70 again. So obviously, since they so graciously gave us almost the exact same numbers, except for the answer, it's 58, then I know I need to move my parentheses. 8 times 7 is 56, plus 2 is 58. Okay, let's look at number 2. Marco solves 24 divided by 6 plus 2 equals, oh no, he says it equals 6. Iris says it equals 3. Show how the position of the parentheses in the equation can make both answers true. It's just like number 3, which I really, really like Eureka because In the problem set, there are always problems that match the exit ticket. Always, always, always. So you can always have your students refer back to their notes in the problem set to help them solve the exit ticket correctly. So let's go ahead and write out our equation with all of our numbers, no parentheses first. So Marco says that it's 6, and Iris says that it is 3. Okay, I know that 6 plus 2 is 8. 24 divided by 8 is not 6. So that cannot be where those parentheses are. So I'll go ahead and put them around the first numbers. 24 divided by 6 is 4, and 4 plus 2 is 6. Well, since I placed my parentheses around the first two numbers, let's put them around the second two numbers. 6 plus 2 is 8. 24 divided by 8 is 3. All right, well, that is our Eureka Math 3rd grade, Module 3, Lesson 11, lesson solution. Have a good day.